Strengths of Materials by Colonel Alan M. Morris. Another piece in the physics puzzle is the force that holds atoms together. Just how atoms are held together, and just how atoms are arranged, either in elemental form or in molecular form, determines just how strong the material is. There are only 4 different strengths of materials. Or perhaps it should be said, that there are only 4 known strengths of materials. In short, they are pulling, pushing, twisting, and cutting. Let's take a better look at these 4. First, how much will a material resist being pulled? Second, how much will a material resist being pushed or compressed? Third, how much will a material resist being twisted? And fourth, how much will a material resist being cut? Let's take a better look at all 4 of these different ways to stress a material. First, how much can a material withstand being pulled? We call that tensile strength. Tensile strength is measured by a cross-section of the material, and its ability to withstand a force in pounds, or newtons. For the purposes of this lesson, we will talk about pounds per square inch, rather than newtons per square meter. Pounds per square inch is also simply called PSI. A very strong material that can withstand being pulled, without breaking is spiderweb material, or spider silk. The trouble with spider silk is that it is difficult to get a great deal of it, but pound for pound, spider silk at 5 times stronger than steel. We have tried to farm spiders, but they are not too friendly toward each other. They eat each other. Silkworms can be farmed, but their silk is not as strong as spider silk. Some research has gone into having cows genetically engineered, so that the cows produce spider silk, rather than milk. That research is ongoing right now, but if the researchers are successful, it will be a game changer. A few more things that have tensile strength are rope, cable, chain, steel, and some polymers, or plastics. Another strength of materials is its ability to withstand being crushed, or compressed. Concrete is a fantastic material for withstanding being compressed. But, concrete has really poor tensile strength. That is, you can't pull on concrete very much, and expect it to stay together. Some rocks have really good compression strength. This is why we build buildings from stones. But there is a limit as to how high we can build with stones. Steel has a much better compressional strength, so we can build skyscrapers with steel and not stone. This was proven by Gustav Eiffel. Perhaps you have heard of, or seen, the Eiffel Tower. No one believed Eiffel, and many people in Paris did not want to see the Eiffel Tower contaminate its skyline. Eiffel was the person who designed the internal, or skeletal structure, of the Statue of Liberty, and as you know, both the statue and the Eiffel Tower are still standing today. Another strength of a material is its ability to withstand being twisted. Some materials are better at withstanding the stress and then strain of being twisted, or torqued. The word torque comes from an old Latin word that means to twist. Torque is measured in foot-pounds or Newton meters. And finally, the 4th strength of a material is its ability to withstand being cut or sheared. There are many different factors that come into play with shear, so there is no straightforward way of measuring it. It is normal to say that a material's shear strength is 60% of its tensile strength. Perhaps you have heard a pair of scissors called a pair of shears. That is because the scissors introduce a shear stress to the material. When a pair of scissors cut paper, or cut plastic, or cut cloth, the scissors introduce a shear stress to the material, and at some point, the material shears. Perhaps you have noticed that some materials offer more resistance to being cut than other materials of the same thickness. That is because these materials have a better shear strength. Soil, or dirt, has very poor shear strength. This is why shovels are shaped the way that they are. Shovels are designed to cut into the soil. The shape of the shovel allows the person digging to cut through, or shear the soil better. Perhaps you have seen entire banks of dirt, or hillsides of dirt, just shear away and slide down the hill. This happens often in California, and other places around the world. The dirt gets too full of water, or saturated. It can't hold itself together any longer, and a hunk of it simply shears away. Materials have many other characteristics, but they will be covered in another lesson. Look for the lab manual below.